Welcome to the deep dive. You've given us just a fascinating collection of information here, and it all seems to point towards one thing, really. Artificial intelligence is moving incredibly fast.
Yeah, it really is.
So over the next little while, we're going to try and pull apart what's happened in, say, the last year in AI. You know, the major research breakthroughs, the big leaps in how well these systems actually work,
Hmm.
and some of the big shifts we're seeing in basically everything from medicine to education.
That's right. The sources you pulled together, they really underscore how multifaceted this progress is. We're not just talking about faster computers here.
No.
It's about fundamental advancements in how AI learns, how it reasons, how it interacts with the world, and it's touching nearly every sector, which makes it both, well, exciting and pretty crucial to understand.
Exactly. And looking at what you've shared, it's clear that AI's fingerprints are, well, they're all over the place. From powering new scientific discoveries, potentially revolutionizing healthcare, to influencing policy decisions, even shaping how the public thinks about technology. It's a lot to take in,
It is.
which is why we're here, really, to be your guides. Our goal is just to distill the most important insights, this real aha moments,
Yeah.
without getting totally bogged down in overly technical stuff.
Sounds good.
So where should we even begin to unpack all of this? Maybe let's start with the engine room of AI research and development.
Okay, yeah. So what's really interesting, kind of a dynamic we're seeing is this. While the number of reported incidents involving AI has jumped quite significantly,
Right.
over 50% in the last year alone, the widespread use of, let's say, standardized ways to evaluate how responsible these AI systems are, that doesn't seem to be keeping pace, especially among the big companies building these, industrial strength models.
That does seem like a bit of a disconnect. You'd think, with more potential for things to go wrong, there'd be a stronger push for these agreed upon evaluations.
You would think so.
But is there any movement on this front? Are we at least seeing new tools or methods for this kind of responsible development?
Yes, absolutely. So while the broad adoption might be lagging a bit, we are seeing the emergence of some really promising new ways to assess crucial aspects of AI, like whether it's generating factual information or if it's operating safely.
Yep.
Benchmarks like Helm Safety, AirBench, and FactTS, these are giving us more sophisticated tools to understand the potential risks and the reliability of these systems. It's a sign that the science of evaluating responsible AI is definitely advancing, even if the practice isn't quite universal yet.
That's a good sign, definitely. It also feels like there's maybe a growing awareness at a higher level, across the globe about needing some kind of framework or guidelines around how AI is developed and used.
Yeah, if we look at the bigger picture, you're spot on. 2024 saw a real increase in international cooperation on AI governance. Major organizations like the OECD.
The Organization for Economic Cooperation and Development.
That's the one, yeah. Focused on global economic issues. So them, as well as the European Union, the UN, even the African Union, they all released frameworks. And the common thread running through these is really a focus on making AI more transparent so we can understand how it works and trustworthy.
That seems pretty fundamental. Okay, so moving from international policy down to, say, educating the next generation, it seems like there's a big effort to get younger students involved in computer science.
What's really encouraging there is the substantial growth we're seeing in K-12 computer science education worldwide. About 2/3 of countries now offer it or are planning to,
Wow.
which is double the number since just 2019. And we've seen particularly impressive gains in Africa and Latin America in making these foundational skills more accessible.
That's fantastic. But I also noticed a mention of ongoing challenges in making this access truly equitable. Where are those issues still cropping up?
Yeah, and this raises a really important point about, who actually benefits from this expansion.
Mm,
In many African nations, for example, basic infrastructure, things like reliable electricity, can still be a major hurdle.
right.
And even in a country like the U.S., while there's broad agreement that AI concepts should be part of core computer science education, less than half of the teachers actually feel they have the training and resources to teach it effectively.
Ah.
So while we're reaching more students, ensuring the quality and equal opportunity, that's not exactly a solved problem.
That makes perfect sense. You can't build a future AI-savvy workforce without both the knowledge and the educators who can actually teach it. Okay, let's shift focus a bit. Another area where AI seems to be making huge strides, the medical field. It sounds like AI is becoming a real catalyst for innovation there.
Oh, definitely. The sheer number of new medical foundation models released in 2024 is truly remarkable.
Foundation models, like the basic building blocks.
Exactly. Think of them as AI's kind of general knowledge base
Yeah.
for a specific domain. Instead of being trained for just one narrow task, they learn from massive amounts of data, which lets them be adapted for a whole range of applications.
Okay.
So in medicine, we're seeing models like MedGemini that's designed to understand all sorts of medical data, text reports, images, you name it. Then you have more specialized tools like EchoCLEP for analyzing echocardiograms,
Heart ultrasounds.
right? Vision FM for ophthalmology eyes, and Checks Agent for radiology, so interpreting x-rays and scans. It's a real sign of AI becoming deeply embedded in various medical specialties.
Wow, that's a lot of highly specialized AI coming online fast. It sounds like it could really speed up diagnoses, help personalize treatments, and it's not just the direct patient care side, is it? I remember seeing something about databases of proteins growing like crazy.
Precisely, yeah. Since 2021, the
Yeah.
publicly available information we have on proteins,
Yeah.
the fundamental building blocks of life, has just exploded. Uniprot, one of the main databases, is up by 31%, another called PDB up 23%, and AlphaFold.
The AI system we'll talk more about.
Yeah, that one. AlphaFold has contributed to a staggering 585% increase in its database. This massive growth in data is incredibly important for scientific discovery. It gives researchers just unprecedented access to info that can help us understand disease, develop new therapies.
That's astonishing. 585%. It feels like we're unlocking so many biological secrets. And speaking of, major scientific recognition, AI research actually got a couple of Nobel Prizes in 2024. That's huge validation.
It really underscores the transformative impact, right?
Yeah.
And the fundamental significance of AI. You had Demis Hassabis and John Jumper from Google DeepMind winning the Nobel in chemistry for their groundbreaking work using AlphaFold to predict the 3D structure of proteins.
Amazing.
And then in physics, John Hopfield and Jeffrey Hinton were recognized for their foundational contributions to neural networks, which are, the underlying architecture for so much of modern AI.
That's fantastic recognition. Decades of work leading to this. Okay, let's talk a bit more policy. It seems like at the federal level in the U.S., progress on AI-specific laws is moving, well, somewhat deliberately. But individual states are being more proactive.
That's a key observation, yeah. While federal action on AI legislation has been relatively slow, U.S. states have really stepped up. The number of state-level laws related to AI, it jumped from just one in 2016 to an impressive 131 by 2024.
Wow.
It highlights a real sense of maybe urgency and innovation at the state level to grapple with the societal, the ethical implications of AI.
It's interesting to see that kind of localized approach to such a broad, fast-moving tech. Now, shifting gears slightly, it seems like there's still a degree of public hesitation, maybe a lack of trust when it comes to certain AI applications, like self-driving cars.
You're right. Despite all the tech advancements, public trust in fully autonomous vehicles in the U.S. remains fairly low.
Huh.
A recent survey showed, I think, 61% of people have fears about them.
Still pretty high.
Yeah, even though that's actually a slight decrease from the peak concern level in 2023, it's just a reminder that, just because the technology advances doesn't mean the public automatically embraces it.
That makes sense. Big difference between an algorithm analyzing data and that same algorithm controlling a 2-ton vehicle. But it seems like when it comes to regulating AI more broadly, there's actually quite a bit of support among local policymakers in the U.S.
That's a really interesting contrast, isn't it? In 2023, a significant chunk, 73.7% of local U.S. policymakers agreed that AI should be regulated. And that's a notable increase from the year before. It suggests that maybe at the level of government closest to communities, where the practical impacts of AI might be felt more immediately, there's a stronger push towards setting up some ground rules.
That's good to know. Now let's dive a little deeper into how AI research itself is, tracked and measured. I noticed some discussion about the data sources used and the potential for certain types of research to be maybe undercounted.
Right, so the AI Index, which is this really comprehensive report on the state of AI, relies on OpenALEC for its publication data, which is great. It's a commendable step towards open, transparent data.
Okay.
However, the report also points out that because they primarily categorize papers under the broad umbrella of computer science, there's a potential for undercounting AI-related research happening in other fields. Social sciences, medicine, even law.
Ah, okay. So if an AI technique is used in, say, a psychology paper, it might not get counted as core AI research.
Exactly. It might not be classified that way in their system.
Yeah.
So it's a valuable resource, the index, but maybe not completely exhaustive picture of all AI-related scholarly work.
Got it. And what about this issue of unknown country affiliations in some publications?
That's another challenge in getting a truly accurate global view.
Yeah.
When the information about an author's institution is missing or maybe incomplete in the publication data, it can't easily be assigned to a specific country, so you get this unknown affiliation.
Why does that happen?
Oh, various reasons. Could be inconsistent data entry, could be authors just not providing the info. It's basically a data quality issue that affects our ability to precisely map the global research landscape.
Makes sense. Really highlights the need for good, clean data in any analysis. Now, who are some of the major players, the ones producing the really highly influential AI research? Any surprises?
At the very top, the names are largely what you might expect. Google, has consistently been a major contributor to the most highly cited AI publications.
Right.
However, in the 2021-2023 period, they were actually tied with Tsinghua University in China. Both had 8 publications in the top 100 most cited. And notably, among U.S. academic institutions, Carnegie Mellon University was the highest ranked for these really impactful papers in 2023.
Interesting. So a mix of industry giants and top academic centers driving the most cited work. What about patents? Where are most AI-related patents being filed globally?
When we look at the geographic spread of AI patents in 2023, North America and Europe, Central Asia accounted for the largest shares. So that gives us an indication of where a significant amount of the innovation and the intellectual property creation in AI is currently happening and being protected.
Okay, that gives us a good overview of the research landscape. Now, the report also mentions these notable AI models. What makes a model notable in this context? What's the criteria?
So Epoch AI, which provides data for the index, defines these notable machine learning models as ones that have a particularly significant impact or influence within the AI research community and beyond.
Why so?
Well, it could be because they set new state-of-the-art performance on key benchmarks,
Hmm.
or they represent a historically important development, or maybe they just get a huge number of citations in academic papers. Examples they highlighted recently include models like GPT-4o, Claude 3.5, and Alpha Geometry. It's basically a way to track the models that are really pushing the boundaries.
Gotcha. And it sounds like the private sector industry is playing a pretty dominant role in developing these really impactful models.
Absolutely. The trend over the last couple of decades clearly shows industry significantly outpacing academia in the sheer number of notable AI models being released. It really underscores the massive investment and intense focus on AI development within the private sector.
Makes sense, given the resources and the direct application potential, right? Now, let's talk about the fuel that powers these models, data. It sounds like the size of the data sets used to train these large language models is just growing exponentially.
That's an incredible rate of increase, yeah. Just to give you a sense of scale, GPT-3, which was the engine behind the original ChatGPT,
Right.
was trained on an estimated 374 billion tokens. Think of tokens as the basic units of text. The AI processes words, parts of words, punctuation.
Okay, 374 billion.
Now, fast forward to the summer of 2024. Meta's Llama 3.3 was trained on roughly 15 trillion tokens. Epoch AI estimates that the size of training datasets for these LLMs is doubling approximately every 8 months. It's a truly massive expansion.
That's just mind-boggling. And with all that data to process, the time it takes to train these massive models must be getting pretty significant too.
Oh, they certainly are. Some of the most advanced models, like Llama 3.1 with 405 billion parameters. Those parameters are essentially the connections in the AI's brain
Okay.
that required approximately 90 days of continuous training. And that's becoming kind of a typical time frame for these really cutting-edge systems. Training these models is just a huge undertaking, both in time and the computational resources needed.
It really puts the sheer scale of these AI projects into perspective, and all that training demands a tremendous amount of computing power, doesn't it?
Exactly. The complexity of the model measured in those parameters we just mentioned, and the sheer size of the training dataset directly dictate the amount of computation required. We're talking models like Megatron Turing NLG with 530 billion parameters, PaulM with 540 billion, GPT-4, Llama 3.1. The amount of raw computing power involved is staggering. And remember, these figures often just represent the final training run, not all the experimental runs during R&D.
It makes you wonder, though, with these data sets getting so enormous, are we eventually going to run out of data, data to train these ever larger models? I've heard that question raised quite a bit.
It's a valid question, definitely an important one. However, some new research suggests that the current pool of internet data that these models are typically trained on might actually last longer than maybe previously predicted.
Oh, interesting.
Plus, there's a growing interest in using synthetic data, that's data generated by AI models themselves, as a potential way to sort of augment real-world data and maybe mitigate any future shortages.
Synthetic data. That's an interesting concept. But I seem to recall reading something about potential drawbacks, like limitations to relying on AI-generated data for training.
Yeah, earlier research did raise that concern, that models trained solely on synthetic data might lose the ability to accurately represent less common or, edge case data points, potentially leading to a decline in the quality and reliability of their outputs, sometimes called model collapse.
Right.
But more recent findings offer a more optimistic view. It looks like when synthetic data is used to supplement, rather than completely replace, real-world data, this significant drop in performance doesn't necessarily happen. It might not always lead to a dramatic improvement, but it doesn't seem to cause the same degree of degradation as purely synthetic training.
That's a promising development then. So maybe data availability isn't the immediate bottleneck. What about the hardware side? It feels like we're constantly hearing about new, more powerful computer chips designed specifically for AI.
Oh, hardware advancements are absolutely critical. Yeah. The progress we've seen in AI capabilities has been largely enabled by significant improvements in the underlying hardware, particularly the development of more powerful and, importantly, energy-efficient graphics processing units, GPUs.
Right.
These parallelized processors are just much better at handling the complex calculations needed for training these huge AI models.
Yeah.
We've seen a pretty consistent improvement in the price performance of these leading machine learning hardware options.
And it's not just raw speed, but also energy efficiency you mentioned. That seems like an increasingly important factor.
Absolutely. The energy efficiency of the leading hardware has improved dramatically.
Huh.
Just as an example, the NVIDIA B100, released in 2024, is over 33 times more energy efficient than the NVIDIA P100 from back in 2016.
33 times. That's huge.
It's a massive leap, not just for reducing the environmental impact of running these huge computations, but also in lowering the operational costs.
That's a really significant gain. Okay, finally, on the R&D front, it seems like the open source AI community is also really active. A lot of contributions happening on platforms like GitHub.
Yeah, the contributions to open source AI software on platforms like GitHub are definitely growing. The United States currently has the largest cumulative number of stars awarded to these projects. Think of stars as like a measure of popularity and community interest.
Okay.
But we're seeing substantial growth in contributions and engagement from other regions around the world too. Europe, China, India. It really highlights the collaborative and increasingly global nature of AI development.
Okay, that gives us a really comprehensive picture of the research and development landscape. Now, let's move on to Chapter 2. Technical performance. Sounds like AI is just rapidly mastering new and increasingly complex challenges.
The speed is remarkable, yeah. The speed at which AI is tackling and achieving significant results on new, difficult benchmarks introduced just last year,
Yeah.
it's pretty amazing. Benchmarks like MMMU, GPQA, SWE Bench, these were designed to really push the boundaries.
Right.
And by 2024, we've seen substantial performance gains across the board. For instance, on SWE Bench, which tests an AI's ability to understand and generate code,
Yeah.
the solve rate jumped from a mere 4.4% in 2023 to an impressive 71.7% in 2024.
Wow. That's an absolutely massive leap. In just 1 year, it sounds like as soon as AI starts to get good at one set of challenges, the bar just immediately gets raised with even harder benchmark.
Precisely. As AI systems get more proficient, researchers are constantly developing even more rigorous, more nuanced evaluations. So now we're seeing benchmarks like Humanity's Last Exam, Frontier Math, Big Code Bench, where even the most advanced AI systems still lag considerably behind human-level performance. This really shows us where the current frontier of AI capabilities lies, the kinds of problems that are still really difficult for even the best AI to solve right now.
So while AI is making incredible progress in many areas, tackling really complex reasoning tasks is still a significant hurdle.
That's a key takeaway, yeah. Even with sophisticated techniques like chain-of-thought reasoning, which encourages LMs to break down problems into smaller steps, they still struggle with tasks that demand robust logical reasoning, particularly in areas like arithmetic and planning, especially when dealing with larger, more intricate problems.
It's a reminder that while AI can process vast amounts of information, true understanding and, step-by-step logical reasoning are still active areas of development. Now, your sources also provided a timeline of notable model and dataset releases in 2024. What were some of the key highlights that really stood out?
Well, several releases caught the attention of the AI Index Steering Committee. OpenAI's GPT-4o was a major one. It's a new multimodal model, meaning
Okay.
it can handle and understand text, audio, images, video, any combination. And it boasts incredibly fast audio response times, almost matching natural human conversation.
Impressive.
Alibaba's Qwen 2 large language model also made waves, showing performance comparable to models like Llama 370B across many different evaluations. And the global MMLU dataset from Cohere is important because it provides a multilingual benchmark to help address the sort of Western language bias that exists in many current evaluations.
Good point.
And finally, OpenAI's O3,
Hmm.
which is still in beta testing, I believe another one of their most advanced models, has shown really impressive results on a wide range of challenging benchmarks.
It sounds like it was a really dynamic year for releases, both new AI models and the data used to evaluate them. And it's interesting that the AI index team is actively curating and even adding new, tougher benchmarks like GPQA Diamond and MMMU to specifically track progress in these more complex cognitive abilities.
Exactly. It's crucial to have a diverse, constantly evolving set of benchmarks to truly understand where AI is improving, especially in those areas that require more than just pattern recognition.
Now, there's a really significant debate within the AI community about the benefits and risks of open weight versus closed weight AI models.
Mhm.
For our listeners who might not be familiar, could you briefly explain the core arguments on both sides?
Sure. So open weight models are those where the underlying code and parameters of the AI system are publicly available. Anyone can access, use, modify them.
Okay.
Advocates for this approach emphasize benefits like fostering broader innovation through wider access, enhancing security and robustness through community scrutiny, and promoting greater transparency in how these systems work. The success of Meta's Llama models, which have been used in tons of applications, is often cited here.
Right.
On the other hand, closed-weight models keep this internal information proprietary. Critics of open weight raise significant security concerns. They warn about potential misuse, spreading disinformation, developing malicious software, even creating biological weapons, and argue for more controlled distribution of these powerful technologies.
Hmm. Feels like there are compelling arguments on both sides. It's a discussion that's likely to continue as the tech matures. What about the trend of smaller AI models? It seems like they're becoming surprisingly capable despite having far fewer parameters.
That's a really encouraging and important trend, yeah. While scaling up the size of models has been a major driver of progress, we're now seeing smaller models emerge that can achieve really impressive performance levels.
Likewise.
For example, Microsoft's Phi 3 Mini, which has only 3.8 billion parameters, managed to score above 60% on the MMLU benchmark. That's a widely used test of general knowledge.
And how does that compare?
Well, earlier models with hundreds of billions of parameters were needed to reach similar scores. So this suggests we might be able to achieve sophisticated AI capabilities with significantly fewer computational resources.
That's incredible. It suggests more organizations, maybe even individuals, could develop and use advanced AI without needing massive computing infrastructure. And it sounds like the field is maybe becoming less dominated by just one or two major players.
That's right. The performance of AI models at the very cutting edge seems to be converging. We're seeing multiple providers now offering highly capable systems. It's a shift from the landscape in late 2022 when OpenAI and Google were largely dominant after ChatGPT launched.
So who else is in the market now?
Companies like Mistral AI, Meta, Anthropic, DeepSeek, they're also fielding top-performing models. This increased competition is likely a positive force for more innovation.
Yeah, absolutely. Now, the report also mentioned some interesting new tools being developed for creating and evaluating benchmarks themselves, specifically Bench Builder and Wild Bench. Tell us about those.
Okay, Bench Builder is fascinating. It's an automated system that uses large language models to actually create and update high-quality benchmarks for evaluating other AI models.
Using AI to test AI.
Basically, yeah. It helps reduce our reliance on the often time-consuming and expensive process of human experts manually designing these tests. In fact, the LMSYS team that created the popular chatbot Arena used Bench Builder to create Arena Hard Auto, which is a particularly challenging benchmark for instruction-tuned LLMs.
And Wild Bench.
Wild Bench, on the other hand, was specifically designed to evaluate how well LLMs perform on more realistic, complex, kind of in-the-wild queries. addressing some limitations of the more academically focused benchmarks like MMLU.
So we're not just improving the models, but getting better, more efficient at testing them in more real-world ways. Another key area seems to be something called retrieval augmented generation, or RG. What's the latest there?
Right. RAG is becoming increasingly important. It works by allowing the model to access and incorporate relevant information from external sources like a database or the internet before generating its answer.
To make it more accurate.
Exactly. Helps improve accuracy, keeps the information up to date. And as RG gets more common, we're also seeing new benchmarks specifically designed to evaluate these systems. Things like Ragnarok and Crag, plus more specialized ones like Finance Bench for financial questions.
Makes perfect sense. You want the AI grounded in accurate current info, and it sounds like LLMs are also getting much better at something called function calling.
Yeah, function calling capabilities have seen significant advancements. The Berkeley Function Calling Leaderboard, which tracks how well models can use external tools and APIs, shows that the top models by the end of 2024 achieved much higher accuracy compared to earlier in the year.
And why is that important?
Well, this ability to interact with external systems is crucial for making LLMs more practical for real-world applications. It lets them do things like schedule appointments, retrieve real-time data, stuff like that.
That's a crucial step towards making AI more integrated and useful day to day. What about evaluating how well these models understand and represent text in different languages?
For that, we have benchmarks like the Massive Text Embedding Benchmark, or MTEB. Embeddings are basically numerical representations of text that capture its meaning, allowing AI to understand relationships between different texts.
Okay.
MTB evaluates how well these embedding models work across a wide variety of languages and tasks. We've seen meaningful improvements here over the past 2 years. Void AI's Voyage 3-meter speech currently holds the top spot, indicating progress in multilingual understanding.
So strides not just in English, but working with many languages.
Good. Now, shifting to image and video understanding. It sounds like AI finally reached a big milestone on the Visual Common Sense Reasoning benchmark.
That's right, VCR, Visual Common Sense Reasoning. It's been a long-standing challenge. AI systems consistently underperformed humans in their ability to understand the relationships and reasons behind what's happening in images.
Yeah.
But in 2024, we finally saw AI systems reach the human-level baseline on this benchmark. It's a significant step forward in visual understanding.
That's a huge achievement in computer vision. And what about more complex tasks involving video, where the AI needs to comprehend actions and events over time?
For these more complex video tasks requiring temporal reasoning, understanding how things unfold over time, we have benchmarks like MV-Bench, introduced in 2023. These types of evaluations push AI beyond just analyzing static images to truly comprehending actions, interactions, narratives within video. It feels like we're rapidly moving from AI identifying objects to actually understanding the dynamics of moving pictures. And the quality of AI-generated images and videos is also improving astonishingly fast, isn't it?
It truly is. If you compare early examples, maybe from the which face is real challenge, to the incredibly realistic, detailed images now coming from models like Midjourney, the progress is just undeniable.
Yeah.
Public evaluation platforms like Chatbot Arena, Vision also let us see how different models stack up. Google's Gemini 2.0 Flash Thinking XP 1219 is currently ranking at the top there for visual generation quality.
And we're also seeing impressive advances in generating entire videos, not just stills from text prompts.
Absolutely. Models like Stable Video Diffusion and OpenAI's Sora have shown remarkable capabilities. Major tech companies like Meta, with their Movie Gen model, which now even includes editing features and sound.
Wow.
And Google, with VO and VO2, which reportedly outperformed competitors in internal tests and user comparisons, they're really pushing the boundaries of AI video creation.
It really won't be long before it becomes incredibly hard to tell real video from AI generated. Okay, let's talk about another crucial area. AI assisting with software coding, another field with immense potential.
Yeah, the state-of-the-art in AI for coding is also advancing rapidly. On the LMSYS chatbot arena, Google's Gemini XEP 1206 currently leads in coding ability, closely followed by OpenAI's o1 and DeepSeek v3 among models from China. These systems are getting increasingly proficient at understanding natural language descriptions of coding tasks and generating functional code.
And it's not just general coding, but also more specialized, challenging areas like mathematical problem solving.
Indeed. Benchmarks for mathematical problem solving, especially those involving complex reasoning, continue to show impressive capabilities in systems like AlphaGeometry 2. This system has demonstrated the ability to solve challenging geometry problems from the International Mathematical Olympiad, the IMO, with remarkable speed and accuracy.
That's truly remarkable. Sounds like AI is becoming a valuable tool even in highly technical, logically demanding domains. The report also mentions something called the ARC-AGI benchmark, aiming to test a more generalized form of learning ability. What exactly is that designed to evaluate?
Right, the Abstraction and Reasoning Corpus, ARC, and its advanced version, ARC-AGI, are unique benchmarks. They test an AI system's ability to learn abstract concepts and apply them to novel, unseen tasks. Unlike many benchmarks that rely on memorization or pattern recognition from huge datasets,
Hmm.
ARC focuses on evaluating true reasoning and generalization from a very small number of examples. It's considered a challenging test of more general forms of intelligence, and we've seen substantial progress here in 2024, with OpenAI's O3 model getting significantly higher scores,
Right.
suggesting a real step forward in more flexible abstract learning capabilities.
That feels like a really key step towards maybe more generally intelligent AI. Now, we're hearing a lot about AI agent systems that can autonomously perform tasks. How are those being evaluated?
AI agents,
Yeah.
yeah, these autonomous or semi-autonomous systems designed to perceive their environment, make decisions, take actions to achieve goals. They represent a really exciting but also challenging area for benchmarking
Why challenging?
because the tasks these agents might perform can be so incredibly diverse,
Hmm.
and the environments they operate in can be so dynamic. There isn't really a widely adopted set of standardized benchmarks yet. Although efforts like Agent Bench and ML Agent Bench are emerging, it's an area where effective evaluation methods are still very much under development.
Makes sense that evaluating systems with such varied capabilities would be complex. Finally, in this technical performance chapter, there's mention of DeepMind's work in robotics and a broader push towards developing foundational models for robotics. Could you tell us about those?
Yeah, DeepMind has continued to make significant progress, including developing Sarah, which allows for faster, more efficient model inference on robots, and
Right.
Aloha Unleashed, which has enabled robots to perform remarkably intricate manipulation tasks, things previously very difficult. In parallel, there's this growing movement towards creating foundational models for robotics AI systems that can understand language instructions and control a wide variety of robots to perform different tasks in the real world. NVIDIA's GR00T is a prime example, a general-purpose model designed for humanoid robots.
Right.
And other companies and research groups, like Covariant with RFM1 and a collaboration between Stony Brook and Wisconsin-Madison on LRA, are also making important contributions in this evolving field.
It truly feels like we're on the cusp of seeing much more capable, versatile robots entering various parts of our lives. And what about autonomous vehicles? Any notable updates there?
Development and deployment continue at a rapid pace. Waymo, for instance, is reporting a significant increase in rider-only miles trips without a human safety driver in several U.S. cities.
Okay.
Meanwhile, in China, companies like Baidu's Apollo Go and Pony.ai are rapidly expanding their robotaxi fleets. And that's being supported by national-level regulations. It appears China is currently at the forefront in terms of real-world testing and deployment of driverless passenger vehicles.
It definitely sounds like the future of transportation is being fundamentally reshaped. Okay, let's move on to Chapter 3. Responsible AI. It's clear that as AI capabilities get more advanced, the ethical considerations become even more paramount.
Absolutely. This chapter delves into the ongoing trends and challenges in responsible AI, or RAI. It starts by noting that while standardized ways to evaluate AI systems against RAI criteria are still not as commonly used as benchmarks for general performance.
Like we discussed earlier.
Right. We are seeing the emergence of new tools like LM Safety and AirBench aiming to fill this gap.
That's a positive first step, but sounds like still a ways to go for widespread adoption and agreement. And I also noticed the number of reported incidents related to AI keeps rising, which is certainly concerning.
It is. The AI Incidents Database documented a record high of 233 reported incidents in 2024. That's a significant increase over the previous year. It really underscores the fact that AI systems can have real-world consequences, positive and negative, and highlights the ongoing need for careful development and deployment.
On a somewhat more optimistic note, though, it appears there has been some progress in making the R&D of foundation models more transparent.
Yes, the updated Foundation Model Transparency Index shows the average transparency score among major developers of these big AI models has improved between late 2023 and mid-2024.
So they're sharing more.
It suggests developers are becoming more open about aspects like their training data, the compute resources they use, the capabilities of their models. However, the index also points out there's still significant room for improvement. particularly when it comes to disclosing details about data access and the copyright status of the training data.
That makes sense. Transparency is crucial for trust and scrutiny. But even with efforts to mitigate biases, it seems that subtle or implicit biases can still persist, even in the most advanced LLMs.
That's a really important nuance point.
Yeah.
Even LLMs explicitly designed and trained to be unbiased can still inadvertently exhibit what we call implicit biases. Research has shown these models can, for example, disproportionately associate negative terms with certain racial groups. They can demonstrate gender biases in the types of careers they associate with different genders. They tend to favor men in their associations with leadership roles. It really highlights the complexity of addressing bias in AI. Simply removing overt biases isn't enough.
That's a sobering reminder of the challenges in creating truly fair, equitable AI systems. Underscores the importance of careful data selection, rigorous evaluation. What about the spread of AI-related misinformation around elections? That was a big concern in 2024.
Indeed. 2024 saw numerous instances of AI being used to create and spread misleading information related to elections across various online platforms, including in the run-up to the U.S. presidential election.
And did it have a big impact?
Well, while the spread of this AI-generated content is evident, the actual measurable impact it had on election outcomes remains somewhat unclear, although many experts had anticipated potentially greater influence.
It feels like we're in a constant race to develop the tools and critical thinking skills needed to tell what's real and what's AI generated. Now, the report you shared outlined some key dimensions of responsible AI. Could you briefly touch upon what those encompass?
Certainly. The key dimensions of RAI generally include privacy protecting personal data, data governance ensuring quality and ethical handling of data, fairness and bias, striving for equitable outcomes, avoiding discrimination, transparency being open about how systems work, explainability making AI decisions understandable, and security and safety protecting systems from misuse, ensuring they operate reliably.
Okay.
So, quick example in a medical context. Privacy means safeguarding patient records. Fairness means ensuring diagnostic tools work equally well across demographics. Explainability might mean an AI articulating why it flagged an anomaly in an X-ray.
Those are all absolutely critical aspects as AI gets more integrated into our lives. And the increasing number of reported AI incidents over the past decade, tracked by the AI Incident Database, really underscores why focusing on all these dimensions is so important. It's not just theoretical.
Exactly. That clear upward trend highlights the growing real-world impact, positive and negative. It reinforces the pressing need for a robust, comprehensive approach to responsible development. And, as we discussed, while there seems to be general consensus among developers on evaluating capabilities, there is still a significant lack of agreed-upon standards for measuring their responsible behavior.
That seems like a fundamental challenge. If we don't have standardized ways to measure responsible AI, it's hard to make consistent progress.
Uh,
What about benchmarks specifically designed to test the factuality of AI-generated information? Are we getting better at ensuring AI models provide accurate, truthful content?
Well, existing factuality benchmarks like HM are valuable, but they're becoming somewhat less challenging as models improve, and they tend to focus on relatively straightforward factual recall. We are seeing the introduction of newer, more complex benchmarks, like Google's FDTS grounding. This evaluates not just the accuracy, but also the level of detail and the AI's ability to ground its answers in provided source documents. Early results on these tougher benchmarks are showing promise.
That sounds like a more rigorous, more relevant way to assess truthfulness in real-world scenarios. Now, how are companies and organizations actually approaching the implementation of responsible AI principles in their day-to-day operations?
Surveys like the Accenture-Stanford Joint Survey offer some insights here. They assess what they call organizational and operational RAI maturity, basically. How well companies have integrated ethical considerations into their structures and processes.
And what are they finding?
Interestingly, the data from 2024 compared to projections for 2025 suggest companies anticipate increasing their maturity in both these areas. It indicates a growing awareness of the importance of operationalizing responsible AI.
That's encouraging. Moving beyond just talking about it to actually putting it into practice. What about the academic research community? Is there a growing emphasis on security and safety aspects of AI?
Definitely. The sharp increase in research papers submitted to major AI conferences focusing on security and safety, nearly doubling in the past year, clearly reflects a growing emphasis on these critical areas within the broader RAI landscape. This increased academic attention is vital for developing the foundational knowledge needed to build more secure, reliable AI systems.
That's a vital area of research, especially as AI gets more powerful and deployed in sensitive applications. Another aspect of our AI is data governance, including understanding the licensing terms of data sets used for training. Sounds like this can be a bit complicated.
It can indeed be quite complex. Research has revealed challenges in ensuring the accuracy of dataset license classifications across different platforms where datasets are shared, GitHub, Hugging Face, papers with code. Licenses are sometimes miscategorized or inconsistently applied, which can create legal and ethical risks for those using the data.
Hmm. Really highlights the need for better tools and practices for data provenance and clarity around usage rights. And of course, privacy, another fundamental element. How is privacy being addressed?
Privacy in AI involves safeguarding confidentiality, anonymity, protecting personal information. We're seeing an increasing trend of websites implementing more stringent data use restrictions, which in turn impacts the availability of web scrape data historically used for training many AI models.
Right.
It reflects a growing societal awareness of privacy concerns and the need for greater user consent and control over personal data.
Makes sense. As AI relies so heavily on vast amounts of data, the rules around data usage become increasingly important. Earlier, we touched on implicit bias in LLMs. Could you give some more specific examples of how these biases manifest?
Certainly. Research shows that even in LLMs explicitly trained to avoid overt biases, subtle implicit biases can still emerge. For example, studies found some advanced models disproportionately associate negative adjectives with text referring to Black individuals compared to other racial groups. We also see persistent gender biases, like stronger associations between female pronouns and traditionally female-dominated professions in humanities, while male pronouns are more strongly linked to STEM fields and leadership roles. These examples illustrate that bias in AI is often nuanced and hard to completely eliminate.
It's clear that just instructing an AI to be unbiased isn't enough. We need more sophisticated techniques. The Foundation Model Transparency Index sounds like a valuable resource here. What are some key takeaways from its latest findings on model transparency?
The most recent version does show an overall improvement in transparency reported by major developers. They are disclosing more info about various aspects: training dataset size, compute resources, general capabilities.
But, as we noted, significant gaps still remain, particularly in crucial areas like providing detailed info on how training data was accessed and whether the copyright status of that data is fully clear. So progress, yes, but still a considerable need for greater openness. Definitely a step in the right direction, but more disclosure needed for trust and evaluation. What about new techniques being developed to improve the robustness of LLMs against generating harmful content or being susceptible to adversarial attacks?
Targeted latent adversarial training, or LAT, is a promising new technique here. Unlike some traditional methods that might just teach a model to avoid or conceal harmful behavior, LAT actively probes and strengthens a model's internal representations during training.
To make it inherently resistant.
Exactly. More inherently resistant to generating harmful outputs and more resilient to jailbreaking attempts where users try to trick the AI into bypassing safety guidelines. Early research indicates LAT can be quite effective and computationally efficient, which is important for potential widespread adoption.
That sounds like a more proactive, effective way to build safer systems. The report also highlights unique RAI challenges with AI agents due to their more autonomous nature. What specific ethical considerations are heightened with these systems?
Well, the autonomous nature of AI agents, their ability to interact dynamically with their environment, their capacity to make independent decisions, it all poses distinct challenges for ensuring transparency, accountability, and overall reliability.
Because they're less predictable.
Exactly. Because they can learn and adapt in potentially unpredictable ways in complex scenarios, it becomes harder to anticipate their behavior and guarantee they'll operate ethically and safely in all circumstances. This necessitates specialized approaches for governing and evaluating these more autonomous AI systems.
Definitely feels like we need new ethical and regulatory frameworks specifically for these autonomous systems. Finally, in the RAI chapter, there's a section on AI and information manipulation, particularly around elections. What were some key examples highlighted?
The report gives several concerning examples. The use of deepfakes to exploit public personas, like fake celebrity endorsements in political campaigns.
Right.
We're also seeing AI algorithms potentially amplifying harmful content, like hate speech, through online echo chambers. And personalized AI-generated video content being used in political campaigns to target specific voter segments.
Any global examples?
Yeah, documented instances of AI-generated misinformation campaigns globally, including the Spamiflash campaign linked to China targeting the U.S. election, and AI-generated images used to try and influence voters in South Africa.
These examples really underscore the potential for misuse, undermining trust, distorting public discourse, highlights the urgent need for tech safeguards and public awareness. Okay, let's move to Chapter 4, Economic Impact and Corporate Activity. Sounds like the data is getting clearer on AI's effects on productivity.
Yes, this year's AI Index provides further confirmation of earlier findings. AI is having a positive impact on overall productivity in many sectors. Several 2024 studies support this and also suggest AI can play a role in narrowing the skills gap between lower-skilled and higher-skilled workers in certain contexts.
That's a really significant finding. Huge potential implications for the workforce. The report also includes a timeline of notable AI-related economic events in 2024. What were some key moments?
The timeline includes several major funding rounds for AI startups, big investments in companies like CoreWeave, Scale AI, also notable acquisitions like Microsoft hiring a substantial number of staff from the AI startup Inflection AI. These events highlight the significant capital investment and ongoing consolidation in the rapidly growing AI industry.
And it definitely seems like generative AI and LLMs are continuing to attract a big chunk of the overall AI investment.
That's certainly the trend we're observing. In 2024, a larger share of overall AI funding went towards generative AI and large language model development compared to the previous year, reflects the intense interest and perceived future potential there.
And geographically, where is most of this new funding for AI companies concentrated? Any shifts?
The United States continues to be the dominant location for new AI company funding, consistently outpacing both Europe and China over the past decade. While other regions are seeing growth, the U.S. maintains its leading position in attracting AI investment.
Okay, clear picture of where the money's flowing. What about investment trends across different sectors within AI? Any particular areas getting more or less focus over time?
Looking at trends from 2018 to 2024, we see investment across a wide range underlying AI infrastructure, healthcare applications, tools for business operations. The specific sector seeing the most growth can fluctuate year to year, depending on market trends and specific tech breakthroughs.
Now, what are corporations themselves reporting? In terms of actual cost reductions, revenue increases they attribute to using analytical AI.
According to a McKinsey survey in 2024, companies are increasingly reporting tangible benefits from their analytical AI investments, citing both reductions in operational costs and increases in revenue across various business functions. This provides concrete evidence of the economic value organizations are realizing through practical AI application.
That's a clear indicator AI is moving beyond just experiments and delivering measurable economic value. What about the overall rate at which organizations globally are adopting AI? Still heading upwards.
Yes, the overall rate of AI adoption by organizations worldwide continued its upward trend between 2023 and 2024. While the pace can vary across different regions, the general trend is one of increasing integration of AI into business processes and workflows.
And specifically, how are organizations leveraging generative AI within their different departments? Any particular use cases becoming common?
The report includes data on the proportion of surveyed organizations deploying generative AI capabilities across different corporate functions, marketing and sales, product development, IT departments. This data indicates broad and growing use of generative AI tools across a wide range of business activities.
Certainly sounds like Gen AI is rapidly becoming a standard corporate tool. Earlier, we touched on AI's impact on productivity. Could you summarize key findings from studies that quantify these gains?
Certainly. Studies from 2023 and 2024 offer compelling data. For example, one found customer support agents using an AI conversational assistant resolved about 14% more customer issues per hour.
Wow.
Other research documented significant productivity increases in fields like management consulting and software engineering through adopting AI-powered tools and platforms.
Really concrete evidence of tangible benefits in various professions. It seems like organizations most deeply integrating AI are seeing the biggest impact.
That's a key finding, yeah. Research suggests a strong positive correlation between the extent of AI integration and the magnitude of productivity improvements. Companies that have more comprehensively adopted AI across different parts of their business are much more likely to see substantial gains compared to those with limited deployments.
So it's not just dabbling. The real benefits seem to go to those taking a strategic, integrated approach. Finally, in the economic chapter, the report mentions continued global growth in industrial robots being installed.
Yes, data from the International Federation of Robotics continues to show a year-on-year increase in the total number of industrial robots being installed in factories and other industrial settings worldwide. Highlights the continued automation of physical tasks and the role of robotics in modern manufacturing.
Okay, that gives a really good understanding of the significant economic impact and widespread corporate activity shaping the AI landscape. Let's now turn to Chapter 5. AI in Science and Medicine, two fields where it seems to offer truly transformative potential.
This chapter really highlights the increasing and profound impact AI is having across both scientific research and medical practice. We're seeing a number of remarkable milestones reached in 2024 across a diverse range of applications.
Let's start with protein folding recognized with a Nobel Prize, as we discussed. What are the latest advancements there?
AI's capabilities in protein folding continue to advance impressively. AlphaFold 3, the latest iteration, has now been made openly accessible to the scientific community, democratizing this powerful technology.
That's huge.
Furthermore, AlphaFold 3 is showing competitive performance in predicting how small molecules, like drug candidates, will interact with proteins, a process called protein ligand docking. Accurately modeling these interactions is absolutely crucial for speeding up drug discovery.
Incredible. Making that tech open source could really accelerate global scientific progress. And it's not just AlphaFold. Other AI models focused on protein sequences are being actively developed too.
Absolutely. Models like ESM3 and ESMC are showing remarkable progress in predicting various protein properties based solely on their amino acid sequences. This capability further accelerates research in structural biology and molecular engineering, letting scientists gain deeper insights into protein function and design new proteins with specific properties. We're also seeing a significant increase in scientific publications leveraging AI in protein science, a real surge of research activity.
Truly feels like AI is revolutionizing our fundamental understanding of life's building blocks. Now, when it comes to AI in clinical settings, are there concerns about the diversity and representativeness of the data used to train these medical models?
There are indeed important concerns. For example, an analysis of U.S. patient cohorts used for training deep learning algorithms in medical imaging reveals a geographic concentration. A significant portion of data originates from just a few states like California, Massachusetts, New York.
And the problem there is
This lack of geographic diversity raises concerns about potential biases in the models and whether they'll generalize effectively to populations in other regions.
makes perfect sense. You want tools trained on data reflecting the whole patient population. What about challenges using AI with more complex 3D medical imaging compared to traditional 2D images?
Data limitations become even more pronounced with 3D imaging, like CT scans and MRIs. While AI historically focused more on 2D, its application to 3D is expanding. But the availability of large, publicly accessible 3D medical imaging datasets remains limited. And there are significant challenges in data standardization due to variations in how data is acquired and processed across different institutions.
So the richer info from 3D imaging comes with hurdles in data availability and consistency. And it sounds like the sheer volume of data used for leading medical AI models is still relatively small compared to the massive datasets for general purpose AI.
That's a critical point, yeah.
Yeah.
Comparing the amount of text and image data for cutting-edge medical AI models to the vast data sets for general-purpose language or vision models, there's a significant difference.
Mm.
A large clinical language model might use tens of billions of text tokens. A general model could use trillions. This relative data scarcity in medicine presents a challenge for developing highly robust, broadly applicable medical AI.
Really highlights the need for more high-quality, diverse medical data to fuel better AI tools for healthcare. Despite these limitations, we are seeing specialized foundation models, specifically for medical applications, emerging.
Yes, a growing trend in developing both 2D and multi-scale vision foundation models in areas like histopathology, microscopic tissue study. These can aid tasks like cancer detection, predicting disease biomarkers. They aim to reduce the need for extensive manual annotation of images and improve diagnostic accuracy. And as we discussed, 2024 saw a significant number of new, large-scale medical foundation models released across various specialties.
Sounds like the field's rapidly advancing despite data challenges, and we're also seeing more AI-powered medical devices getting regulatory approval, like from the FDA in the US.
That's a clear indication of AI's increasing integration into mainstream clinical practice. The number of FDA approvals for AI-enabled medical devices has seen a significant upward trend recently. Reflects growing confidence in their safety and efficacy and a better understanding of how to regulate them.
A really important step towards bringing these tools into everyday healthcare. The report also highlights a promising role of synthetic data in medicine. How can generating artificial data help here?
Synthetic data, artificially generated data, mimicking real-world data, holds significant promise in medicine for several key applications. Research suggests it can help AI models better understand social determinants of health, those non-medical factors influencing outcomes.
Okay.
It can enhance privacy-preserving methods for predicting clinical risks, and even facilitate new drug discovery by providing more data for training AI models and drug design. By creating this artificial but realistic medical data, we can potentially overcome some challenges of data scarcity and the need to protect patient privacy.
A really innovative approach to address limitations of working with sensitive real-world medical data. And going back to the recognition, the 2 Nobel Prizes for AI-related work in 2024 really underscore its profound impact in fundamental science and practical medicine.
It truly does. The Nobels in chemistry and physics acknowledged AI's transformative contributions, from deciphering intricate protein structures to laying foundational principles for the neural networks powering modern AI.
What about more direct applications in assisting patient care? How is AI supporting healthcare professionals day to day?
Research indicates advanced AI models like GPT-4 can assist with various patient care tasks. And interestingly, their performance often improves when insights are combined with physicians' clinical expertise.
That's key.
We're also seeing development and pilot adoption of ambient AI scribe technology. These systems aim to automatically document patient-physician conversations, reducing administrative burden on doctors, letting them focus more on patient interaction.
That sounds like it could be a real game changer for reducing physician burnout and improving care quality. And AI is also being used to extract valuable info from the vast data in electronic health records.
Yes, specialized language models fine-tuned for the medical domain are being used to automatically extract key information, like social determinants of health, SDOH, directly from EHRs and clinical notes. These models show strong performance and often exhibit less bias compared to other methods of extracting this crucial social context impacting patient well-being.
A really powerful application for promoting more holistic, equitable healthcare. Finally, in the science chapter, mention of notable AI foundation models in other scientific domains beyond biology and medicine. Examples.
We are indeed seeing powerful foundation models emerge in other disciplines. For example, Aurora is a large-scale model for Earth science forecasting state-of-the-art predictions for air quality weather patterns.
Cool.
And FISBERT is notable as the first physics-specific text embedding model, outperforming general models on tasks related to understanding and analyzing physics research papers.
Yeah.
These examples highlight AI's broad growing utility as a powerful tool across diverse fields of scientific inquiry.
Truly remarkable seeing AI become such an indispensable tool for scientific discovery and advancing medical knowledge. Let's now shift to Chapter 6, Policy and Governance Developments. Sounds like some significant events on the global policy stage in 2024.
2024 was indeed a pivotal year for AI policy globally. The European Parliament gave final approval to the landmark EU AI Act, the world's first comprehensive legal framework for regulating AI.
Huge deal.
The UN General Assembly also adopted a U.S.-led resolution with broad international support, promoting safe, secure, and trustworthy AI. Additionally, the UK and South Korea co-hosted an AI Safety Summit in Seoul, building on previous discussions.
Sounds like really significant steps towards establishing international norms and legal frameworks. Any other notable policy events or pronouncements globally?
Yes, in the U.S., a federal judge issued an injunction temporarily blocking a new California AI law aimed at regulating harmful depictions in deepfakes, citing concerns about its definition.
Interesting.
On the investment front, Saudi Arabia announced a massive new initiative, Project Transcendence, a $100 billion commitment aiming to establish the kingdom as a global hub for AI tech and innovation.
Wow, $100 billion. So progress on regulation, some pushback, and massive national investments. What about AI-related legislative actions at the individual country level, beyond these major events?
Several countries took specific steps. For instance, Latvia introduced new regulations on using AI in political advertising, requiring clear disclosure for AI-generated content. And Russia made amendments to personal data laws, specifically addressing AI use in processing personal information. These examples show how different nations are starting to grapple with AI's specific societal and ethical implications through their own legal frameworks.
Definitely sounds like a patchwork of approaches as different countries navigate these complex, fast-evolving issues. Turning back to the U.S. seems like a significant increase in AI-related bills proposed federally, but the number actually signed into law remains relatively small.
That's a key observation. Yeah. While there's been a marked increase in AI bills introduced in Congress, the legislative process for actually passing them into law has been comparatively slow. Likely reflects the complexity and ongoing debate about the best ways to regulate such rapidly developing tech.
And it seems like individual states are continuing to be more active in enacting specific AI laws.
Yes, we keep seeing specific examples of new state-level AI laws. Colorado enacted Senate Bill 205, addressing AI use in insurance practices. California passed the social media platform Duty to Children Act, with implications for AI use on platforms frequented by young people. These state actions reflect a diverse range of concerns and approaches within different jurisdictions.
Interesting to see this more localized, state-by-state approach in the U.S. Now let's talk public investment in AI. The report analyzes spending in the U.S. and Europe. Key differences or trends.
The AI Index report cautions against direct comparisons between the U.S. and Europe due to differences in data collection. However, their analysis reveals interesting distinctions in spending priorities.
Size.
In the U.S., the largest portion of federal AI spending in 2023 went to the Department of Defense. In contrast, in Europe, public AI investment saw larger shares directed towards sectors like public services, education, healthcare, with defense accounting for a significantly smaller percentage. Highlights potentially different strategic priorities for public AI investment.
Really notable contrast in how public funds are directed. Finally, in the policy chapter, the report looks at how often U.S. congressional committees mention AI in reports. Any trend there?
The AI Index analysis found a significant increase in mentions of artificial intelligence in U.S. congressional committee reports recently. Indicates growing awareness and engagement with AI issues in the legislative branch, even if, as we discussed, this increased attention hasn't yet translated into a large volume of enacted federal laws.
Okay, that gives a comprehensive overview of the policy and governance landscape. Let's now turn to Chapter 7, the AI education landscape. Preparing individuals with skills and knowledge for an AI-driven world is increasingly crucial.
This chapter defines AI education broadly encompassing both AI literacy, a general understanding of AI concepts, and societal implications,
Right.
and developing technical skills to actually build and deploy AI systems. It highlights significant challenges in building a robust, diverse AI workforce, stemming from disparities in infrastructure access, quality educational resources, and overall participation in relevant coursework.
Makes perfect sense. A thriving AI ecosystem needs an informed public and a skilled workforce. What's the current state of foundational computer science courses in K-12 schools across the U.S.? Seems like a critical building block.
Availability varies considerably based on socioeconomic status and geographic location. Schools with higher percentages of students eligible for free or reduced lunch, often indicating lower socioeconomic conditions, and schools in rural areas tend to have less access to these crucial introductory CS courses compared to wealthier and urban suburban schools.
So, still significant equity gaps in accessing this foundational CS education, and these gaps also exist along racial and ethnic lines.
Yes, analysis of access by race and ethnicity reveals persistent disparities, with some student groups having less opportunity. While efforts to broaden access have led to near or even above proportional representation in CS enrollment for some groups, incomplete data from several states means we need caution interpreting these trends. Additionally, there's still significant underrepresentation of girls taking AP computer science exams, indicating a gender gap there.
Sounds like while progress is being made expanding CSUED, substantial work is needed for equitable access and participation. What's the global picture? Integrating AI-specific concepts into K-12 curricula.
Globally, relatively few countries have explicitly integrated AI education as a distinct subject in K-12 yet. More commonly, AI education's importance is discussed in national strategies, but concrete implementation plans are often still developing.
So where is it being taught?
In many cases, AI topics are currently addressed within broader CS or ICT education frameworks. Tracking CS-ICT availability globally serves as a proxy, but remember, these are sometimes conflated with basic digital literacy skills.
So largely early stages of formally incorporating AI-specific learning worldwide. What about post-secondary education in CS and AI in the US? Seeing growth in students pursuing these fields.
Yes. The number of bachelor's degrees in computing fields in the U.S. has seen significant, consistent increase over the past decade. However, looking at representation of different racial and ethnic groups within these programs, bachelor's, master's, PhD levels, we still see disparities. Some groups are underrepresented compared to their overall proportion of the U.S. population.
Highlights the ongoing need for initiatives to diversify the talent pipeline in CS and AI at the higher ed level. Finally, the report includes OECD data on new ICT grads at short-cycle tertiary and master's levels across countries. What does that indicate about global tech talent production?
The OECD data for 2022 gives a snapshot of new ICT grads at both short-cycle tertiary, typically more vocational technical programs, and master's levels across OECD countries. The U.S., for example, shows a relatively high number of master's ICT grads, while other countries might focus more on the short-cycle level. Reflects differences in national education structures and priorities for producing skilled tech workers.
Okay, valuable overview of the AI education landscape, US and globally. Let's move to our final chapter, Chapter 8. Public opinion on AI. How are people generally feeling about artificial intelligence these days?
Overall, we're observing a notable increase in public optimism towards AI globally in 2024, particularly in several countries previously more skeptical: Great Britain, Germany, the US, Canada, France.
Interesting shift.
This shift is also reflected in increasing positive opinions globally regarding products and services using AI, comparing 2022 to 2024 data.
That's interesting, seeing that shift, especially in initially more cautious regions. Are there still significant regional differences in perceiving potential benefits versus drawbacks?
Yes, perceptions continue to vary considerably. Respondents in Asia and Latin America tend to express more optimistic views. A greater proportion believe AI will ultimately have more benefits than drawbacks. In contrast, populations in Europe and the Anglosphere tend to maintain a more skeptical outlook.
So, cultural context, perhaps different tech experiences, likely play a significant role in shaping attitudes. Finally, any noticeable change in public concerns about specific AI issues like data privacy or potential bias?
Looking at year-over-year changes on specific questions, the AI index observes a slight increase in overall concern. This is primarily driven by a small average decrease in public trust that companies using AI will adequately protect personal data,
Oh, okay.
and a similar slight dip in trust that AI systems will avoid discrimination and not exhibit harmful biases.
Suggests that while general optimism might be rising, underlying concerns about ethical implications and potential risks remain important in the public consciousness. Well, this has been an incredibly detailed, insightful deep dive into the current state of AI, drawing from the comprehensive sources you provided. To put it all together, what would you say are some key overarching trends that really stand out?
Well, we're seeing incredibly rapid advancements in AI capabilities across a vast range of domains: NLP, computer vision, robotics, scientific discovery. There's growing recognition of responsible AI's importance, although establishing and implementing standardized practices remains a significant challenge.
Right.
The economic impact is becoming increasingly evident: substantial investments, demonstrable productivity gains. AI is emerging as a truly transformative force in science and medicine, leading to exciting breakthroughs. The policy and governance landscape is evolving quickly, with significant regulatory developments internationally and nationally.
Mhm.
Public perception is generally becoming more positive, though concerns about ethics and risks persist. And finally, while efforts to build a strong, inclusive AI education ecosystem are expanding, considerable challenges related to access and equity still need addressing.
It's clear the field is incredibly dynamic, multifaceted. These insights provide a valuable snapshot of this rapidly evolving landscape. So for you, the listener, considering this ongoing tension, rapid progress in AI capabilities versus slower adoption of responsible AI practices, what do you believe is the most critical area of focus to ensure a beneficial future with AI? Or, with AI increasingly integrated into sensitive domains like healthcare and governance, how should we best navigate the balance between fostering innovation and upholding fundamental ethical considerations and public trust? Just some important questions this deep dive brings to the forefront. We encourage you to keep exploring these topics, consider the implications of these trends for your own understanding of this transformative technology. Thank you for joining us for this deep dive.